In this quick tip, let's keep on talking about matrices and quaternions. So here we have Craig, and what I like to do is have some kind of smoke simulation along the eyes. Now, if you know anything about smoke, you'll know that we have a bounding box that our DOP simulation is allowed to think within, and because Craig is walking forward, what's going to happen to this box is that it's going to get stretched out. And the bigger that box gets, the longer it takes to simulate something. So it's really not ideal that we have geometry here that's moving around. And many times you'll have simulations where you don't want the geometry moving around like this. Craig is moving pretty slowly here, but if let's say you had an asteroid that was zooming past your scene, going really fast, then you can't just have a bounding box for your smoke simulation get huge. It just wouldn't work. So let's take what we know about matrices to solve this problem. I'm going to start with a attribute wrangle, set it to detail, and I'd like to capture the position of one of these points. Now here I'm working with packed geometry, and so with packed geometry, they're represented by points. If I press W for wireframe, you can see some of these points here. It kind of goes in and out because of the viewport. Let's click the numbers, and there is the point number. Now, each point will correlate with a piece of the geometry. So I want to read the position from piece number 3. That's Craig's head. That's where we're going to constrain the emission geometry for the smoke. So let's say this, V for vector at capture pos. Let's capture this position using the point attrib function. Point attrib will read a point attribute from geometry stream 0. Let's look for position, that's P, and create our own channel, which is an integer, that is the point number that we would like to capture the position on. And lastly, we also want to have 0 at the end there so that this whole thing works. Press that. Point number is going to be 3. Now, if I go to our geo spreadsheet, we have captured this position. The next thing to do is to create a transform. Transform, right-click translate, reference, local attributes, and let's go for that capture pos that we just made. At first, it's going to look a little bit weird because we've basically applied that point's position twice to the location of Craig. However, if we check this box, this invert transformation, we will essentially pin Craig's head to the origin, which is great. This is very ideal for working on if we have a smoke sim. Now, once we have this, how do you reapply a transformation? Well, first of all, let's add the sphere here, which will be our emission geometry. I've already gone ahead and positioned that, so let's just merge this in. There's our sphere right along there. Now, to reapply this transform, it's very easy. All you need to do is just make a duplicate, hold down Alt and drag out to do that. Y to cut, plug that in, and then uncheck this invert transform. Simple as that. Now we have the sphere and Craig moving along just fine. However, you'll notice a pretty big issue, and that is the rotation is not being followed with his head. We have the transformation fine, but the sphere is not being rotated properly as he's moving around. So let me show you a cool technique for extracting rotation. Let's use a extract transform. And what I'm going to do is I'm going to start by extracting the transform of Craig and his head specifically. So if we go back to Craig without the sphere, and he's down here at the origin just kind of doing his thing, I basically want to extract some kind of attribute that can be applied to our sphere to account for that rotation. What this node needs is it needs the target geometry, that is the geometry that's moving around, the animated geometry, and it needs to compare that against geometry which is sitting still. In other words, our rest position for this character. So the rest position is going to happen for us by using a time shift node. By default, it uses $F But if I hold down Control-Shift-Click, I can then just delete that expression, put in 1, and now we have Craig frozen at frame 1. Let's compare this against the animated rotating Craig, and what we will get is we will get an orient and a pivot. The orient is going to basically describe the orientation of the points. But before we get there, notice how we just have one point that's happening here. In order for this to work with multiple pieces of packed geometry, you need to use this piece attribute right here. It's going to look for name, which is the primitive attribute which defines each piece on Craig. And it's going to create a point for each one of those pieces and also creates an orient attribute which describes its orientation. Whenever you see this orient, this is a quaternion, and it's going to describe the rotation with 4 values. So this x, y, z, I like to think of it like that, describes essentially where things are pointing towards. And this fourth value here is going to describe how much it's being rotated. So here's a side example of what orientation is doing for you. Here I've just isolated Craig's head, and I have this control sphere above. Now within Vex, I've basically said to assign the orientation attribute, the first 3 values of that orient attribute, to a vector, which is pointing in the direction of the control sphere. If we go to our Geo spreadsheet, we basically see that the first 3 values, again, can draw a vector or some sort of direction facing towards this sphere. Now, as I mentioned before, the 4th value is all about rotation. So think of it like this, and I'm going to relate this back to the very first quick tip I did about quaternions. Remember when I dropped in the toothpick and I twirled the toothpick? Well, here I have a vector, which again is accounting for where this toothpick is. And as I go to apply rotation, right here, I'm essentially twirling that imaginary vector. If, let's say, I decide to put the toothpick or the vector somewhere else, like, let's say, over here, again, it's just drawing out a vector. It's kind of taking the toothpick, putting it this way, and I can rotate. So all we need to do now is we need to select which piece we would like to extract the orient attribute from. I think the easiest way to do this is just to use a blast. So I'll just say blast right there. As far as the point number goes, I can just create a reference to this. So copy parameter, paste relative reference. Let's say points, and then delete non-selected so that we're left with just that. There's one more node we need in order to apply this rotation to the sphere, and that is we need a transform pieces. Transform pieces needs the geometry to transform. That's going to be our sphere right here, and it needs a template point. Here is our template point. Now that we have this, we have Craig. He's walking around. We have rotation. It's being applied to the sphere, and it's all working just fine. I hope you've enjoyed this quick tip. And what I've decided to do is make a mini course that's all about quaternions and matrices. I still really haven't gone into the technical details of those. I'd like to really show you guys how you can build your own rotations through Vex, as well as through the VOP context, and give you different ways or options to do the same thing. And I'd also like to just show you more practical examples of where this stuff comes in handy. So if you'd like to support these tutorials, check out cgforge.com. And if you decide to unlock this, you'll also have access to any future videos I do that are related to quaternions and matrices. Until then, thanks for watching, and have a great day.